Hello and welcome back to another fun and exciting lesson in pre-calculus. My name is Mr. Bean. Today's lesson is going to be on domain and range with a specific focus on the graphs, how to find domain and range based off graphs. But before we get into that, we're going to talk about a couple other things, first of which is the 12 basic functions. Now if I move too fast, don't forget to pause or rewind. The idea here is that you're going to recognize in this first one, why don't you write down that it is what it's called as a linear function. Underneath here we have what's called the parent graph. This is f of x equals x. This is the parent graph. All other graphs will stem from this that are linear functions. So every single line. So we might have, this is just so you understand what I'm talking about, f of x equals negative 3x plus 1. So if I had negative 3x plus 1, I was trying to graph it. That is some type of translation of the original parent function. So everything that we're writing down here, when you'll see this on every graph, that's what's called the parent function. So you will need to memorize then both the name of the basic function and the parent graph's equation for each individual one. So there's 12 of them. Okay, so that's the first one. I'll try to give some little hints on how to remember some of them. A lot of these you'll be very familiar with. Here we have the quadratic function, and its parent graph is, of course, f of x equals x squared. This is called a parabola. We'll get into these this year. We'll see some of those. Then you have a cubic function. The cubic is where we're raising it to the third power, so x cubed, and we'll have different variations. Sometimes the cubic function will maybe look like this. It'll have a little bit more waves in them, or we could be flipped around and so forth. Then we get to the rational function, and you will have, this is asymptotic, meaning that we have some asymptotes that go up and down right here, right in the middle, both left and right, horizontally and vertically. And then the parent function's equation is 1 over x. That's the original parent graph. And we have square root function. Square root function, it starts here. You'll notice that it equals square root of x. You notice nothing is over here in the negatives. So it starts right here at 0, 0, and then it goes off. Now this is not an asymptote. It continues on forever and ever, going up and to the right. Okay, so it gets flatter, but it doesn't actually ever become flat. It continues to increase. Exponential function. This one does have an asymptote, and so if you need to remind yourself, this has an asymptote right there, in which this graph's going to get closer and closer as you move to the left side, and then it grows away, going up forever. And it doesn't have to be the number 2. This just needs to be some constant. The important thing here is that the x is in the exponent here. We'll get into those again, of course, later this year, but that's just a 2. It doesn't have to be a 2. It could be really anything down here. Next is the logarithm function. A logarithm function, f of x equals log of x, and we'll get into these later as well, but this is a vertical asymptote right here. You'll have a vertical asymptote. There is no asymptote that's a horizontal. It might look like it, but it is just kind of flattening out. Never really gets flat, though. Continues forever and ever. Then we have the sine function. Now this is a wave, and the sine function, spelled S-I-N-E, when you write it with the f of x, it's f of x equals sine x. Now don't pronounce this sin x, it's sine x. And the difference between this one and the cosine graph, which we'll write here, so write down cosine function, and it is spelled C-O-S. Don't pronounce that cos or cos, it's cosine. It's just an abbreviation. So cosine function. And if you'll notice between the two, so let me go back to the sine function, what I might help you remember is that the sine function is going to pass through the origin right here. Okay, so if you notice this, sine function is going to go through the origin, and then the cosine function, when we look at that one, when x equals 0 here, the y value is a 1, so it has a maximum point here. So the maximum and the minimum's here, but it starts at the maximum at x equals 0, whereas the sine goes through the origin. Okay, hopefully that will help you memorize that. And then the absolute value function. This one hopefully is familiar to you. Absolute value of x, just right there at the origin, has a sharp v. It's not a nice rounded curve. It's like 2 lines that come together. Greatest integer function. This one is similar to, it's actually a variation on a piecewise function. You have all these different pieces, and it's like this, the int, integer of x. But the piecewise functions will be something that we get into, I believe, in our next unit. Now, logistic function. This last one here, it's kind of a crazy equation down here. F of x equals 1 over 1 plus e raised to the negative x. Okay, so it's kind of a long one. But if you, this one has 2 horizontal asymptotes, which is kind of crazy. You don't usually see that very often. horizontal asymptotes where you have two of them. And so you have, it's kind of like a ceiling, but I think of this as a ceiling and a floor. So we'll get into this logistic function as well. Kind of cool stuff here that we'll deal with later. So for now, all you have to know is recognize from the graph. Can you recognize what the name of it is? In this case, logistic function. And can you write out the parent equation, the equation of the parent function? Next part of our lesson is what's called increasing and decreasing functions. We're going to identify the intervals on which a graph is increasing and when it's decreasing, and actually also when it's constant. Now, I took this idea actually from coolmath.com. They had a really good example that I liked, so I'm kind of stealing it from them. I want to make sure I give the credit to them. And here we have a graph that's going up and down and up, and then it's flat here. So before we get into this, let's talk about a little ant. I'm going to name this ant Timmy. Now, little Timmy, when he walks along things, he always walks from left to right. Okay, that's the direction. So when you look at a graph, you always want to think the ant, little Timmy, is starting on the left side and is marching along towards the right. So in this example, we have that the ant is moving left, and then it's going down here, and then it starts crawling back up. So when is little Timmy going uphill? When Timmy is going uphill, that is where the graph is increasing. So for this example, let me get my colors out here, we're going to put an open parentheses, negative infinity, comma, and then when does he get to the top of the mountain? Right here at negative 3. Negative 3. So we're talking about what's called x values. So the x values is the interval from negative infinity way off here to the left until he gets to negative 3. Now, at that point, that's when he starts going down, so he's not increasing anymore. But right here, when we get to the number 1, he will be increasing again. And so we're going to say 1, comma, 4. Now, notice I left some space in between here. That was on purpose. This space here, I'm going to put this symbol that looks like a U. It's not actually a U. It stands for union. So it is both negative infinity to negative 3, and it's including 1 to 4. So this is our parentheses. This is not a coordinate point like you're used to. This is an interval from this point to this point. All right, so the graph is increasing on those two intervals combined. Now let's talk about when is little Timmy going downhill. Well, he gets to the top of the mountain here, and then he slides down. So this part where he's sliding down is where the graph is decreasing. So if Timmy is going downhill, the graph is decreasing, and that is on the interval from negative 3 until you get to the x value of 1, and then we close our parentheses. So from negative 3 to 1, that's decreasing. Now, why am I using parentheses and not brackets? Now, if I said a bracket of negative 3 to 1 and then bracket like this, that's wrong. But if I were to use that, then that would mean that we're actually going to include the negative 3 and include the number 1. But we're not doing that. And the reason why is because if you zoomed in on this and looked at what if we were right at the top of that mountain peak and the little Timmy got right to the top and then stopped right there. Is he increasing or is he decreasing? He's not doing either. He's not sliding down. He's not going up. He's just kind of that one exact spot is not going up or down. And so we don't include it in the interval notation here. We just leave it as a parentheses instead of including it for the point. All right, and then the last part is constant. When is Timmy on a constant slope? So the graph is constant when it's flat, and that happens from the value of 4 until he gets to infinity, meaning never. He never will stop. It's going to be constant for the rest of the time. And that's how you do increasing and decreasing for functions. So what I want you to do now is pause this video, try and do this one on your own. I will have the answers just pop up here so you can see if you've done it right. All right, pause it now. And there are your answers. You can check to see if you did this right. Forgive my infinity symbols. I'm really bad at making these. People tell me they look more like a Pringles chip. So, sorry. Okay, so check this. If you've got this one on, go ahead and skip to the next example problem. And I'll explain this one right now for those of you who didn't get this. So, increasing. Let me show the increasing parts. So, we're going to increase here. We're going to increase here, because this is where little Timmy would be crawling uphill, and here. Those are the parts where little Timmy, the ant, would be crawling uphill, moving left to right. So those are the intervals on which we put. And again, we say the x values are the intervals. Negative 5, negative 3, negative 1 to 1, and then 4 to 5. And then decreasing. Let me get rid of those red marks. Decreasing is where if we move left to right, it's going downhill. Now this is where some people say, but Mr. Bean, the arrow is going up, and if the arrow is pointing up, it should be increasing. No, this is decreasing because you always move left to right on these graphs. So if you're moving left to right, we're actually going downhill. Little Timmy would be going down there and then down here. So there's two intervals that we join together with a union symbol, and that's what these two come from. And then the last one is the constant, and it's flat horizontal line, or in other words, the slope is 0 right here on those two intervals. So -3 to -1, and then 5 off to infinity. Next up in the lesson is identifying the domain and the range by only looking at a graph. This can be a little bit challenging for students, so we want to pay attention here, and a lot of your assignment will be doing this. What I've got here is a gray box. I'm going to cover up the graph. Now on your notes, what you can do is just you can use another piece of paper or your hand. Basically the way this works is you cover up the whole thing. This will help us, trust me, this will really help you identify the domain and the range much easier. So what we're going to do is list the smallest domain value. Well, domain values are all of the x's. So you'll look at the very smallest x value by moving over and trying to figure out where is this left side of the graph, the furthest thing to the left. Ah, there it is. Okay, so it starts at -2. So you come over to your graph and we're going to do a bracket -2. Now, why did I do a bracket? Because it is including the -2. If this had been an open circle, I would do parentheses -2 instead, because it would not include that point. A bracket includes the -2. Then I'm going to say comma, and then it continues until you get to, now I'm going to keep dragging this thing over and revealing the graph. How far over does it go? It keeps going and going and going and going, and then finally it does not stop. It just keeps going forever, and so it goes off to infinity. So then I come right over here and say infinity. Okay, that was pretty bad. Now, infinity is always with a parenthesis. It does not ever have a bracket because we can never actually get to infinity. It's a number that just keeps going forever and ever. So we don't include infinity. We just say parentheses infinity. That is the domain using what's called interval notation. Now here's an inequality notation, and that's where we are just going to say, let me write it out here and I'll explain it. X is greater than or equal to -2. This is inequality notation where we use a less than symbol or a greater than symbol, and we say all of the x values that are from -2 on up. That's what this statement means. Okay, so these two things are exactly equivalent. It just depends on the directions of the problem, if it wants interval, if it wants inequality, or if it wants both. Now, all that work was just for identifying the domain. So now let's go back and identify what the range is. So we're going to go down here, cover this whole thing up again, and then we think, all right, range. Range are y values from the top and the bottom. So let's start with the smallest range. The smallest is going to be on the bottom. So we start moving this thing up, and there it is. So what's the smallest y value? It is a 3. So we're starting, let's go back to we're starting with interval notation. We go bracket 3, comma, and then you keep moving it up and up. And how far up does it go? Well, this is an arrow that really goes up forever and ever and ever. And so this one also goes on for infinity. And we do a parenthesis. Now the trick with the inequality is because we're doing range, we have to use a y value. So it's all the y values that are greater than or equal to, that are bigger than this y value. So it's greater than or equal to 3. All right, there's our first problem on those. Let's try another one. We're going to do the exact same thing with number 4. So either use another piece of paper or use your hand, and we will cover up that graph. Now to identify the domain, the smallest domain value, we will move this thing. Let's start dragging it, and we look for the farthest thing on the left, which in this case right there, it is a -2. Now it doesn't have a filled in circle, but on all of our graphs, we can assume that it is filled in right there, that it's actually touching -2. So we're going to say bracket -2, comma, and how far does it go? It keeps going to the right, it keeps going. So we're only looking at x values, and the x values keep going forever and ever and ever and ever off to the right. So it's just like example number 3, and this one goes to infinity. There we go. All right, how about the inequality? This one again is all of the x values that are greater than or equal to -2, just like the first problem that we did, or excuse me, the last problem we did. All right, range. Now we cover it up again, so cover it up with your hand or another piece of paper, and we're going to slowly reveal from the smallest range value, which would be on the bottom. So we start revealing, and then look here. What is the smallest range? There's an arrow here that it keeps going forever and ever. Therefore, the smallest range is -infinity, comma. Now, how far up does it go? It keeps going and going and going and going, and it never stops. See, so the y values, if you notice, there's never a break in any y values. It keeps going forever. Therefore, we say it goes to positive infinity, close parenthesis. Okay, well, now how do you say this with inequality notation? You don't really do it like this. What you say is all real numbers. Now, all real numbers just means everything. But there's a shortcut to writing all real numbers, which is nice. It's this symbol right here. It looks like an R with two little lines on it. So it's an R with two lines. This stands for all real numbers. That can be placed right here as well if you want to just write it like that, all real numbers, instead of having to hand write it all out. It means the same thing. So these two things are equivalent. Okay, number 5. So let's try number 5 on your own. You're going to pause this video, try this one, see if you can get the same answers as I do. And just so you know, this red dashed line, that is just a little an asymptote to help you understand that the line is just going to gradually get closer and closer to that line. Never actually is going to touch it, though, on this example. And there's your answer to number 5. Let me show you how we do this one. It's a little bit more complicated than the ones we had before. So let's start off with domain by covering this up. Again, if you already have these answers and you know it's correct, if you want to skip ahead to the last problem, number 6, then you can do so. If you need some help doing this one, let me show you how it works. So as we start revealing the left side of the graph, the domain, the farthest one on the left, is actually -infinity because it keeps going forever and ever. That's why I put a -infinity right here. Then as we keep scrolling along, and we reveal, it stops once we get to the number 4. So the x values, we go off to -infinity and come up here to the number 4, and it stops. But because it's an open circle, I put a parenthesis at the end. So -infinity to 4. And that's the same thing as all of the x values that are less than 4. Not less than or equal to, just less than 4 in this case, because it's open. All right, now let's do the range. So the range, you start revealing the smallest range value. The ranges are the y, so you start on the bottom. And then you can see here it starts at -2. We assume with graphs that it actually touches that point, so we're going to say it's at -2 with a bracket. And then it keeps going. Now this is where it gets confusing for kids. They want to say it stops here at this value of -1, but it does not stop here because it's included there. So if you see, it's continuous this whole time. It never breaks of y values. Think of it like this. If I, as you're coming up here, right there at that point, it may not exist there, but it does on the left side, so you have to include it until you get to a y value of 3, which is the asymptote. So -2 to 3. And then the way you write the inequality is that it's the y values that are in between -2 and 3. All right, that was a lot. That was pretty quick. You might have to rewatch that part and rewind if you didn't understand this number 5. We're going to go on and do the last problem, number 6. Okay. This one's pretty tough. Let's get my box here to cover it up. So take your hand or another piece of paper, cover the graph up, and let's start with domain. Begin slowly revealing the left side to figure out the smallest domain value. And where is it? There it is right there. So we're going to start at -3, but recognize that it is an open circle, so we will do parenthesis. I probably should have written smaller. In fact, let's do that again. Write fairly small because I think there's a little bit more we're going to write on this one. So we start at -3, comma, and then let's continue until we get to where it stops. So here we have a vertical asymptote, and so it gets to -2 but never actually touches it. It's just going to approach -2. So we will say it gets to -2, close parenthesis. Now we do a union symbol, and we go back and start revealing. Okay, so there's a break here. When does it pick up again? It picks up right there at an x value of 1. So we're going to say it restarts at 1. It's an open circle. And then it continues until we get to what value? A value of 4. This is where kids will make a mistake by saying it ends at the value of 4. But if we do that, okay, don't write this part down. If we say 4 here with a bracket, then we'd say we're going to do a union of, and then we would continue on from 4. Well, that would make no sense because what we'd be doing is saying, hey, we're going to, let's get that out of the way. We're going to end at 4, include 4, start at 4 again. Really, we don't need any of this then. We don't need to say we're going to end at 4 and then continue on at 4. There was never a break here. So we just keep going until it finally stops, which in this case is at the value of 6. So we're going to say 6 with a bracket. So we go from -3 to -2 for the x values, and then we start here at 1 and we continue on. There's never a break. See, because at 4 here it's still included. It never stops until you get to 6. There's interval notation. All right, now how do we do inequality? We're going to say, let's see here, we're going to have 2 statements. We'll say -3 is less than x, which is less than or, nope, just less than -2. And we also have, whoops, that's and we have 1 less than x, which is less than or equal to 6. So once you have the interval notation, you just kind of step by step write out the inequality notation. All right, let's see if you can do the range on your own. If you want to pause it right here, just finish this off, and that'll be the end of our lesson. I'll have the answers appear here, see if you can do that part right. So remember, the range, you're focused on the y values. And there's your answer to number 6. We have -∞ to -2. As you reveal here, you can see why that is. -∞ because the arrow goes down, and then as you come up here, see there might be 2 pieces, but if you look at only the y values, these are the same y values. So it goes -∞ up to -2 as you scroll up here, and then if you keep going, where does it start again? When you get up here to 3, and then it continues up until the y value of 6, and it stops. So you're looking at the y values again. Okay, you did it. This is Mr. Bean signing off. Rock that mastery check, and I'll see you back in the next lesson.